Alrighty, hello. Today what we're going to do is fractional distance on a number line, and we're going to apply that tonight to a coordinate plane. It's the same idea, you just do it twice for the x's and the y's. So with fractional distance here on the number line, what we're going to do is we're going to find point M on line segment LN that is 1/3 of the distance from point L to point N. So you can see we've drawn the number line here. We've marked the points L and N, but we don't know where M is. We have to find that. And it's got to be 1/3 the distance from L to N. So the first thing we want to do is we want to realize, since this is about distance, we want to find the distance from L to N. So remember, the distance Ln is equal to the absolute value of the second point minus the first point. And in this case, the second point would be the 5. So the absolute value of 5 minus the first point is -1, so we're subtracting a -1. And remember that the absolute value bars act like parentheses or grouping symbols. So we do what's inside first, and then we do the absolute value to that. So 5 minus -1, remember minus negative becomes plus. So this would be absolute value of 5 plus 1, which is the absolute value of 6. The absolute value, recall, makes the number positive inside. The technical definition is it's the distance from the origin, or how far away from 0 is it. So 6 would be 6 units away from the origin. So 6, and that is our distance Ln right now, Ln. So that's part way there. We're almost there. Now what we want to do is we want to go 1/3 of that distance. So we're going to take 1/3 times that distance, 6. We're going to get 1/3 times 6 is going to be 6/3. Remember, we think of it as 6 over 1. Maybe do that in gray to remind you that that's just something you're thinking about, 6 over 1. So now you can realize that 1 times 6 is 6, 3 times 1 is 3, and 3 does go into 6 2 exact times. So now we are 2 units away. That 1/3 of the distance is 2 units. And notice up here it says from L to N. So we're going to go from the left to the right, from the L to the N value. So going from the left to the right, what that means is we're going to go from the low point, -1, to the right. We're going to add that amount, that 2 right there. And so when we get -1 plus 2, we end up finally with the answer of 1. And that is the location right there. That is 1/3 the distance from L to N. So look at it. That's 1/3, 2/3, 3/3. Right? Each one of them is 1, 2, 1, 2. I drew that one a little far. And 1, 2. So 2 units each. It's 1/3 of the way there. Now, if we had instead said from N to L, so let's change that up here, from N to L, then we would have still found the same distance. We would have still found 1/3 of that distance right here, getting the 2. But then we would have gone from the right to the left instead. So we would have gone from the high point, 5, and we would have gone to the left, so we would have been subtracting 2 units, 5 minus 2, and that would have given us an answer of 3. 3 would have been 1/3 the distance from N to L, so going that direction, you'll notice. So 1/3 that distance is right, actually, where did I mark it? Sorry, is right there, 3. So that would be if we went from the other direction. Make sense? Think about that. This is 2 different questions. First one was from L to N. The second one was from N to L. So I want you to see that direction difference. So then the next thing we're going to talk about is a ratio distance. So it's essentially the same question, but asked in a different way. This time what we're going to do is we're going to find M on line segment LN such that the ratio of LM, the distance of LM, to the distance of MN is 1 to 2. So the first thing we have to do here is we have to take a look at the ratio, this part right there. That ratio is a very important part to us. So what we have to realize is for LM, the distance of LM, to be the same as the distance from MN, we would have to multiply this by 2 times. That's what that 1 to 2 is. So This gets 1 unit, this needs 2 units. So we'd have to double this to be the same amount. So notice it kind of flipped sides, didn't it? So then what we're going to say is we're going to look at the betweenness of points theorem, where we're going to realize that the total distance Ln is equal to the Lm distance plus the Mn distance. And now what we can do is we can substitute right here, that's Mn, and plug it there. Well, this is what we're going to put there, because that's the same. So we're going to say it equals the first Lm, that one right there, plus the 2Lm up here. And so now it equals, if we add that together, thinking about algebra, those are the same variable, the distance of L to M. There's 1 distance of L to M plus 3 distance of L to M, plus 2 distance of L to M, gives us 3 distances of L to M. So, now what we've got, using the betweenness of points, we got that. So now what we can do is we can go ahead and solve this. We can say Ln equals 3Lm. So then divide out the 3. We get 1/3 Ln equals Lm. So Lm, the distance from L to M, is equal to 1/3 of the distance from L to N. That's up here. Now realize, that right there, if we write it out, find M when the distance from L to M is 1/3. That's essentially the same question we answered right back here, right? Find M on Ln, that is 1/3 the distance from N to L. So that's essentially the same thing. So we would find it in the same way. We'd go ahead and continue. We'd find that same answer being right up here at 1, because we'd still do 1/3 the distance. We'd find that distance here is 6 units. We'd multiply that by the 1/3. We'd find it's 2 units. And so from the L to the M that we're looking for is 2 units. Now notice what we did. I set this problem up so it would be the same answer, and that's exactly why. Okay? So I hope this helps, folks. When it comes to doing this on a coordinate plane, it's just doing the same thing for the x's and the y's. You just have to do the process twice. Okay? Right on. Have a good one, and I will see you in class.